I'm going to continue to solve the exercise about the special functions. And these exercises, they are going to be about absolute value function. Now, absolute value function is given and they are asking to write them in piecewise form. Now, if you remember when I explained the absolute value, I said like this: if we close the term here, what is written here, if we close this term, then there is one term inside the absolute value and it can get a positive value or negative value. It is not important. Outside we are going to write positive form of it. So we don't know what is written inside the absolute value. That's why it's going to be like this: x plus 3. There are two possible cases. X plus 3 will be greater or equal to 0, or x plus 3 will be less than 0. Okay, there are two cases like this: greater or equal to 0 and less than 0. There are two cases, and from these two cases we are understanding that the critical point is minus 3. X will be greater than minus 3, or x will be less than minus 3. Greater or equal to minus 3, less than minus 3 is going to be. Okay, if x plus 3 is greater than 0, the function is positive. X plus 3 is less than 0, function is negative. Okay, then I'm doing like this. Here, minus 3 is the critical point for us, and the function fx I'm writing. Fx is equal to, here, when the values are x plus 3, sorry, it is not the fx, actually, this is x plus 3. X plus 3 is greater than minus 3, positive, is less than minus 3, negative, it's going to be. When you choose one value greater than minus 3, let's choose minus 2. Minus 2 plus 3 is equal to plus 1. So the intervals that on this interval, the values, they are going to be positive. In this interval, the values are going to be negative. To make the... Now I'm asking the absolute value of x plus 3. Absolute value of x plus 3, absolute value of x plus 3, the result always must be positive. So for the positive result, if the number is negative, you should multiply by negative sign. Plus 3. If the number is negative, you should multiply by negative sign. And this absolute value of x plus 3 should be minus x plus 3 to be positive, because number is negative here. Negative and negative, that's going to be positive. So here, fx is equal to, on this interval, fx is equal to minus x plus 3 on this interval. And here, the positive, when the values are greater than minus 3, function is positive, which means positive function, you are not going to change the sign of it, because if the number is positive, you don't need to do any operation there. So the fx is going to be equal to x plus 3 there. Okay, after all these explanations, fx has two different function value. One of them is minus x plus 3, one of them is x plus 3. Sorry, I made a mistake here. This should be, when you multiply by minus sign, you should multiply by all the values here. So this is going to be minus x minus 3. Okay, minus x minus 3. So I need to change also this one here. Okay, minus x minus 3. When it is, now I wrote two different functions. This seems as a piecewise, but I should mention the boundaries also. Boundary here, it is 3. I said the critical point is 3. That's why with respect to 3, we are going to use this one. When the values are less than 3, function is negative. Function is negative, as you see here. When the values are less than minus 3, function is negative. So this should be less than 3. And this should be greater or equal to 3, because when the values are greater than 3, when the values are greater than minus 3, when the values are greater than minus 3, function is x plus 3 is positive, so positive side is this side, is going to be. So this form is the piecewise form of the absolute value function. Okay. The next question, quadratic equation. Quadratic absolute value. So x squared minus x minus 2, like the previous one, will be greater than 0. or will be less than 0. X squared minus x minus 2 will be less than 0. If you remember the solution of these two questions, it is similar. It is similar. On this question, we are looking for the greater values. On this side, we are looking for the negative values. We are looking for the negative values or less than 0 values. That's why critical points of these two questions, it's going to be same. How to find the critical point? If you remember, we were factorizing this one, x minus 2 and plus 1 I'm going to write here. Minus 2 plus 1 is going to be minus x, and the sum, the crossly, if you multiply, this is minus 2x and minus 2x, and this is going to be x, and the sum is equal to minus 2x, and this, minus x. The factorization is going to be true for us. So the function is x minus 2 times x plus 1 is greater or equal to 0. If I factorize this one, I'm going to find the same factors also. That's why I'm not doing that one. Okay, now with respect to this one, the first critical point is 2. The second critical point is equal to minus 1. And for the quadratic inequalities, we were drawing the table. The fx is equal to x squared minus x minus 2. And the critical points are minus 1 and 2. If you remember, this side represents minus infinity, this side represents the plus infinity. Already we didn't mention here, this side is also representing minus infinity, and this side is representing plus infinity, but we didn't mention that one. In quadratic inequality especially, we are mentioning that one also. Now the signs are plus, so we start from plus on the right side, we were starting, and then minus, then plus it's going to be. These pluses and minuses I tried to explain before the meaning of it. This means the function is greater than 0, less than 0, greater than 0 in these intervals. So between minus infinity and minus 1, function is positive. Between minus 1 and 2, function is negative. So when the function is positive, absolute value of x squared minus x minus 2. When I say on the positive intervals, there's no need to multiply by a number positive, because it is already positive. There is no need to change. But when the number in this interval, you should change the function. You should multiply by minus sign, x squared minus x minus 2. You should say to that one, and that's going to be equal to minus x squared minus x minus 2, and that's going to be equal to the last one is going to be x squared minus x minus 2 is going to be again this one minus x squared plus x plus 2. It's going to be. So as you see, I wrote 3 different functions here, but actually the first one and the last one is same. So there are 2 different functions here. This is the last step now. Fx is equal to, there are 2 functions. One of them is x squared minus x minus 2. The other one is x squared plus x plus 2 is going to be. In which intervals? X squared minus x minus 2, these 2, they are here, minus infinity, minus 1. When the values are minus 1, less than minus 1, and when the values are greater than 2. When the values are greater or equal to 2. Here, greater or equal to 2 and smaller than minus 1, these are positive sides. That's why I add the 0 to the positive side, because non-negative it should be. And here, between minus 1 and 2, the function is negative. That's why we multiply by negative sign and we made it positive, if you remember. So in this interval, the function, it should be like this, and this is the piecewise form of the function is going to be.